So, Ashant, welcome to the summit.
Hey, Danjo. Great to be here. Thanks for organizing. Awesome job so far.
Thanks, man. We're all excited to see your angle of the prospecting and outreach and how we can utilize the AI.
All right, let's get into it. All right, this is going to be a little bit of a different talk. And the angle I'm going to take is I'm going to connect our profession, sales and marketing, to the climate goals that are ahead of us. It's going to be a little bit technical as well. So time to jog your brain a little bit and probably make the connections by yourselves on how this could convert into sales for you. So a little bit about myself is that we are a digitalization company. The title of my talk is Digitalization for Climate Goals. And the point of the talk is to help you see the digitalization opportunities in the digitalization space where you can actually benefit the climate, work for the climate goals that we have as we go through our professions on a daily basis. So a little bit from where I'm coming from, I'm the co-founder of PowerOn. PowerOn is an ERP company. We have our own ERP for the photovoltaic installation companies. So a roof like this is companies that are installing these kind of roofs and harnessing solar power. They use our software to run their sales, run their warehouse, run their purchase departments. The whole SVP is solar power plant construction projects, the finance side of things, and the maintenance and help desk. These things last for about 30 years. They stay on roofs on a daily basis, harnessing solar power. So it's been our goal since about a year to serve this industry and make our contribution to the climate in that angle. And to basically get the bread and salt on the table, we do B2B sales, and once the sale is done, then we execute the ERP project at the customer side. And we're a SaaS company, by the way, so our software is offered as a software as a service. All right, net zero 2050 is the big call. And just as a teaser, what are the climate goals? By 2050, humanity has declared that they will be carbon neutral. Which doesn't quite mean that we won't be emitting any carbon dioxide, but it means that we won't be emitting any carbon dioxide into the elements. And the elements are the air, the water, and the soil. So that's a goal we have declared. We've got ourselves a time frame of about 26 years and 1 month, or 1.5 months, and we need to get there. Where, in other words, keeping the planet livable is what we're going after. And let's take stock of the situation. So we've got on the top 3 stars we are emitting 38.8 gigatons of CO2 per year. That's 9 zeros. We are consuming 24.4 terawatts. That's 12 zeros of power planet-wide every year, and only 13% of our waste is being recycled. So these are huge numbers, and the 13% of waste recycling gives you an idea about how much needs to be done, that we get to a point of sustainability where we are actually maximizing the utilization of the resources we're extracting from the earth. Now, as I tell all these facts and this whole narrative about the climate, what you need to be doing, everybody in the audience, is to actually compute in your mind how many business opportunities are lying here. We'll get to that in just a second. So the first 3 bullet points are sort of on the deficit side. What's the damage we're causing? But the last 3 bullet points are about what's the progress we're making. So 30% of the energy is already that we consume of the 24.4 terawatts is actually already renewable, is from renewable sources, primarily hydropower and wind power. 100 million households will have solar by the end of the decade. That's where we are making a very tiny contribution, but nevertheless very meaningful for us. And the last point is sort of the killer for everybody here, in the audience is that $52 trillion of investments are necessary to achieve the net zero goals by 2050. That's 52 trillion with 12 zeros. And in the next 25 years, this money is going to be spent and sort of like circulate in the economy for addressing this problem at a human scale. So at this point, you should be asking yourselves the question, that's a pretty big number. How can I get a piece of that action, right? Okay, let's move on. So digitalization is the topic for my talk, and the digitalization does help in significant ways to fix the problem. I'm going to take the next maybe 10 minutes to go over the main bullet points on how this is happening. So overall, if you sort of like drill down into it, engineers are going to solve this problem, right? You have two big mountains and a little girl has to cross over or wants to cross over from one to the other. The engineers can build a bridge for them. You have two big numbers, you want to multiply the two, an engineer has to build a calculator for you. Also, this massive problem of climate change, the engineers are the guys who are going to be solving them. And digitalization is a tool for these guys in order to help them to actually reach their goals and help us as humanity to reach our goals. And while the engineers solve those problems, we in B2B sales, we are the communicators. We are the transporters of the solutions into the market. We are the ones who are actually taking the orders on a daily basis. No matter who solves the problem, the company, we are the ones who are actually generating the revenue in terms of actually enabling the circulation of that 52 trillion that's coming up. So those being sort of like the bold strokes, drilling down, the major engineering is happening in generative design, what's called a generative design. We'll just look into it in a second. There's additive manufacturing. This is a big new thing that's happening in engineering. Process efficiency, that is our topic, providing software as a process efficiency technology, and co-creation, collaboration. So break these down in a few minutes. Let's just go straight into generative design. All right, before we move into a little, so digitalization, you know, with all these products, all these technologies, cloud, AI, and all the hype words and the mega trends and everything that's been happening for the last 50 years in the digitalization space, basically it comes down to a relatively simple paradigm. You have data, you process that data, and you obtain certain outcomes. Take a good old humble spreadsheet, right? You put a lot of numbers into it. You process those numbers through a macro or a formula or something like that, and you get an outcome. You do a profitability calculation, you do a sales forecast, you do something interesting like that. All programs basically do that, and that's what digitalization has been. Now, generative design is the textbook definition of it. To the side of the slide is AI-aided, automated, interactive design process with sensor feedback in real time. That's a mouthful. So basically, if you map the old paradigm of data processing and results and outcomes, you have the new tech, automation, AI, etc., that are fitting this paradigm. And the only new thing that we have been doing in generative design is to actually feed back the results into the data so that there is a feedback loop built into the engineering and design process through which the outcomes can be optimized better. Now, that's more engineering talk, but I want to take a second to show you a video about what is generative design. This comes from Autodesk, the maker of AutoCAD engineering software, and they're explaining the paradigm of generative design.
Dozens of options for a single design without drawing, all of which meet specific goals set by the designer. And from those options, pick the one design that delivers on the most important criteria, the design you couldn't possibly have imagined. This is generative design, a technology that harnesses massive computing power, creating forms with precise amounts of material only where needed. achieving maximum performance while wasting nothing. But generative design can be about much more than simply turning out alternatives. Prototypes can be scanned and equipped with sensors that provide real-time performance data that can be looped back into the design process, so the object, in effect, co-designs itself. And depending on the material and method of manufacture chosen, the software can optimize the design for those choices. In its search for the optimal design, generative design creates complex forms that would otherwise be impossible to make using traditional manufacturing methods. Now, with advancements in material science and the ability of 3D printers to print metal, companies like Airbus can create forms like this airplane partition panel that's half as light and just as strong. The result? Significant reduction in fuel costs and CO2 emissions. The things that have limited us in the past, software, materials, manufacturing, can no longer do so. With generative design, the world can look and perform any way we lose. This is the next stage in the evolution of design, and it's happening now.
All right. Thanks to Autodesk for that. And I've got, before I play the next clip, the way to think about generative design is to think about digital twins. So you may have heard of this term. You have a physical entity. Let's think about a car. You create a digital model of that car using sophisticated tools, computer software, and all the paradigms of using AI and various other paradigms, cloud computing, edge computing, etc. You put a digital twin of that. You run the whole paradigm, and you run the whole simulations, and you run the whole algorithms on all of them, and measure the outputs that are coming out. And finally, take the outputs and feed them back into the engineering loop, so that you come out with ever more optimized results. And you do this with the climate goals, with the CO2 goals that we have in the next 20 to 25 years. Then you actually take a feedback of how the climate outcomes are going to be, and we'll watch that in the next slide. So I'm going to take a second to play, to give one last stroke on the generative design paradigm through this video clip, and let's take a look.
Project. So we just took an off-the-shelf race chassis and put 50. Language of goals and constraints. Basically, you frame the problem in terms
You're
of
gonna have to do this
the HackRod project. So
right.
We just took an off-the-shelf race chassis and put 56 sensors on the tension points of the chassis. The HackRod team drove that thing out in the desert under extreme conditions.
From there, that data was analyzed and input into one of our generative design systems, Dreamcatcher, and a new chassis was grown.
So this is one of the first times that data has been able to be gathered in the field on performance, fed back into the design to improve the design. So that.
Okay, so that's digital twins, that's generative design. By the way, the word generative, you probably have heard about this in generative content, generative graphics. The whole paradigm of large language models is a generative paradigm. So they're doing the same thing. They are measuring the outputs, putting it back into the computing, and then continuing the process until finally they have optimized outputs. So enough about the generative design. Let's move on to the next big paradigm that's being deployed by the engineers to solve the climate problems, and we in sales should know about it.
The HackRod project.
All right. So let's skip over that, and let's look at additive manufacturing. My slides are a little bit all over the place. The videos play without without me intending. Let's talk about additive manufacturing for a second. And additive manufacturing is basically a paradigm of manufacturing where you add material to form a certain physical component instead of, as in old days, remove material. So the old paradigm of making physical products, let's say you want to build a chair, is you get a large piece of wood, you cut it until the point that you're able to put a chair together. Additive manufacturing is eco-friendly, uses lesser resources because you add components as you need them according to your design. You add material according to your design rather than removing material. That's what additive is about. And to demonstrate this, I took a little video from a company called Trumpf. It's a local company here which does high tech and is probably the best of their breed that deploys additive manufacturing using laser cutting for using laser for metal formations. So let's just take a look at the video here, 2 video clips to get the point on additive manufacturing. So what if you notice there was material being added. It was basically metallic powder that was being added. The laser was actually forming the object as it went through. More and more material got added, and finally the form was made. And all the material that was not used is going to be used in the next production cycle. So that's basically just metallic powder, which is going to be used in the next manufacturing cycle. I'm going to take you over to one more clip to get the point about additive manufacturing. And
We're taking a fluid mixer and building it into a heat exchanger. Fluid lines will flow within the curvature of the part. This was an impossible part until now. Bottom of the part, we have 2 separate inlets that'll take fluid and mix it together into a single set of channels and produce a mixture coming out of the top of the part. On the side of the part, we have 2 ports that'll take a different temperature of fluid and flush it through that center cavity and encourage a heat exchange. We printed out a 316L stainless steel with 20 micron layer height and no supports. You know, we looked at the part geometry, a couple of the angles were right on that threshold of potentially needing supports or not needing supports. We looked at the machine's capabilities and we said, you know what, let's take a risk. Let's put this machine to the test. Wow, that is incredible. It's the same part I've ever printed in my life. The machine delivered. So the cool thing about this machine is we can manufacture parts like this that would be impossible using traditional manufacturing methods without a lot of design changes and assembly steps. And we did it completely unattended. I went and handled other tasks. I came back, I raised the part out of the powder bed, and I was blown away at the level of detail that it achieved. So from here, we're going to have to cut our part off our build plate. To help with that, we added a little bit of material at the bottom so that we can make a nice clean cut and maintain our flange thickness. So we're really just scratching the surface of what this technology is capable of. This thing can print hip joints, it can print aerospace parts, it can print lattice structures. This technology is literally changing people's lives.
So that was another good explanation of how additive manufacturing is actually the next paradigm in manufacturing, where the only the materials are taken from the nature, which are going to be used to form the object. All right, so we've had generative design, we've had additive manufacturing, and yes, by the way, if you're already thinking about 3D printing, this is the same paradigm. Only 3D printing is thought of as, you know, a little bit, if you want to do a figure of a Spider-Man and do it very quickly and cheaply, that's called 3D printing. Additive manufacturing is the industrial hardcore stuff. All right, so that's two down in how the engineers are tackling this problem and how and why we should know about that in sales. Let's move on to the process efficiency. This is something that you guys know. Anybody who spent any time in the software industry or the IT industry, generally speaking, you've heard about these paradigms. Just in time, for example, is a very eco-friendly method. If you need 100 parts, buy 100 parts, and hence only 100 parts are manufactured by the supplier rather than a whole batch of 1,000 parts, which is a little bit of a higher stress on the nature because 1,000 parts have to be made and they'll just be waiting for you to use them, and probably a certain percentage of that could also be wasted. So software, digital technologies actually help to make these workflows happen as we go through various supply chains in many industries, thousands of them all around the planet, and just applying these paradigms and using the software tools that are either available or could be easily made available, you start to have an impact on the climate because you're being more resource efficient. The typical ERP functions, don't want to harp into that, but that's our daily business, to provide these tools to businesses so they can get by with more efficiency through their of mainly manpower and also materials on top of that. People have bought software and digital technologies for manpower efficiencies, but slowly we're seeing the benefits, sometimes almost for free and automatically, that being efficient on the manpower front can easily translate to being efficient on the material front as well, which has an impact on CO2 emissions. The whole share economy, just to also not leave that out, is you have if you could share a car with a neighbor or with a family member, you're basically reducing the need to produce another car. And yes, there are also discussions and arguments about, hey, isn't that not going to shrink the economy? And those kind of discussions, it actually will not shrink the economy. We are actually talking about, in the next 25 years, a $50 trillion expansion of the economy because we have new problems to solve. So the old paradigms were suitable for old problems. We have new problems now, and hence the economy is transforming into a solution provider for the new problems. So the share economy is probably just a teaser, and there's going to be much more and more. And some of the things that we are seeing today in terms of generative, in terms of additive manufacturing, these are the paradigms that are actually going to get us to the climate goals, and we should be aware of that as business people. All right. Moving on, and last not least, co-creation, collaboration. That's what we're doing here right now. So the digitalization is already helping us to cut our transportation CO2 footprint. We are just able to go around the world. I'm sure most of you, if not all of you, have done a small or a big deal just online without ever having to produce any CO2 footprint in terms of getting to the customer. And this is not to underrate the necessity or just the beauty of meeting people and knowing your customers in person. That's what makes our jobs human too. But there's a lot of efficiency that's possible. So in the old days, without meeting a customer, you would never get an order. That's changed, obviously. And we're doing all these kind of things like e-learning, e-governance, the e-commerce, e-meetings, e-signatures, and everything in that line. So that's already happening. So that's digitalization addressing the CO2 issue once more. So that's about it. So let's wrap up. What do we have now? Digitalization is impacting climate problems. B2B salespeople must know about this, and there's a $52 trillion transaction opportunity in the next 25 years, and we will all be still be here. And I think our careers will sort of see that day that we have achieved those climate goals, and hopefully all of us today here will contribute in a small or a big way to that. We talked about generative design, we talked about additive manufacturing, we talked about process efficiency technologies like ERPs, and we talked about collaboration, co-creation tools across the internet. So that's the end of my talk. My name is Ashant. You can look me up on the internet, and I still use email. Thanks a lot.
Well, Ashant, quite technical presentation. Let me look up some of the questions order. Yes, there was one question actually. Question to Ashant, how can we actually utilize the generative AI or additive manufacturing to help us with the actual prospecting and sales?
Well, the point of my talk would be you can separate this as a teaser for the new operation, new opportunities that are emerging in the climate space. So my talk was not so much about giving you the skills about for cold calling or the prospecting, etc. But I think on the topic of prospecting, you could just look out the window. There's a lot happening in the social media. There's a lot happening. Anywhere you see a solar, for example, or a wind power plant, and you start to connect the dots on the business that is behind that technology that's out in the field, you will start to see that there are white spaces all over the space which are not being served. And another thought deeper into that, you can see how a sales and marketing person, which are basically communicative, persuasive traits, right? These are also needed in the climate space. So you could do the compute on any area you pick on the climate. Recycling is a big opportunity, right? So I'm just picking off the top of my head. 13% of our waste is recycled, but what about the other 87%? Why is that space not being addressed yet? What are the companies working in that area? How could they be helped through sales and marketing people who are out there, doing their prospecting, etc.? These are the questions that could trigger you in that direction on contributing to the net zero of 2050.
Got it. So the climate space and the net zero has some upcoming sales opportunities, especially into the manufacturing part, where there could be a lot of upcoming sales opportunities in the coming 25 years, you said?
That's right. Yeah, 26 years and 1.5 months we have before 2050.
I hope I'll retire by then, so I won't need it. But Ashant, thank you very much. I see that there are no additional questions at this stage.